An electron is accelerated from rest through a potential difference of 1250 volt. If the potential difference is halved, calculate the ratio of electron new speed to its original speed and the ratio of the electron new wavelength to the original wavelength. Okay, so here you can see it provides you with the first potential difference, and then later on we have potential difference is halved. That means here we have two potential difference. We put the first one as V1, and then the second is V2. The one which is half is V2. Yeah, just right over here. This is V2. Yeah, which is halved. Okay, all right. Now the ratio of the electron new speed and original speed. So original speed is the small v. Yeah, this is small v. The potential difference is big V. The speed is small v. And then the new speed is V2. Okay, we have V1 and V2. And then we also have the original wavelength and the new wavelength. That means we want to find ratio. Ratio, that means you need to, later we see. So original wavelength is lambda 1 and new wavelength is lambda 2. Okay. So now we want ratio of new speed to original speed. That means the question asks for, we want the answer in new speed to original speed, the ratio. That means V2 ratio to V1, which is you write in fraction form. V2 first, new speed first. New speed means V2 on top and 2 original speed at below. So we need the answer in V2 over V1. And then the second question is about wavelength, new wavelength to original wavelength. So new wavelength to original wavelength, which is we want the new wavelength at the top and original wavelength at the below. Okay, so we want this value. Let's find out how to get this answer. For this, we have two conditions, two situations. Situation 1 and situation 2, I like to divide into 2 columns. I gather the information at 2 columns, so this work is more systematic. Yeah, it's more systematic this way. So we have condition 1 and condition 2. Just write down all information provided. V1 is 1250 and V2 is half of it. Half of it is we already have the value for V1, so we can calculate for V2. So for V2, half of it is 1250 divided by 2, which is 625. V2 is 625 volt. Alright, so now V1, V2 we don't have, and then lambda 1, lambda 2 we also don't have. So how to do this? Okay, how to do this? So this is about the electron accelerator, isn't it? Electron accelerator is using this formula, which is actually, this formula actually come from the change in potential energy become the change in kinetic energy, the conservation of energy. So it's EV equal to half mv square from potential energy change to kinetic energy because of accelerating chamber. Okay, potential energy change to kinetic energy. So EV equal to half mv square. Okay, so this formula can relate between the voltage, because he gives us the voltage, isn't it? He gives us a voltage, want us to relate to the velocity speed, yeah, velocity v. So this formula, it has the voltage here. You see here, it has the voltage. It also has the velocity. The speed. The rest is what you can see is this electron. This electron charge. Are we using different atom or different? We use different things like different proton, neutron. No, we just use electron, isn't it? We just use electron. So for both condition, for both condition, we also use the electron. So the electron is a constant. Electron charge is a constant. Okay. So the charge is electron, yeah, constant for both. And then for the mass also, we are only using the electron. We don't use proton, we don't use neutron, we don't use neutron is a neutral charge. Why talk about neutron? Proton, we don't use proton. Okay, we don't use any ion. We only use electron. Yeah, we only use electron. So the mass of electron is a mass of electron. We just use the mass of electron. So both of these charge and the mass, they are both constant. Understand? The charge and the mass is both of electron. So they are all, we are using the same thing. We just use the electron. So the charge and the mass is constant. Use the charge of electron and only the mass of electron. Okay, so we can say the E and the mass, the charge electron and the mass of electron is the same, constant. So the only variable in this equation is only the voltage and the velocity, isn't it? The only variable. Because we change the voltage, we will expect changes in the velocity. Yeah. So these two are the variables. So what I can say is all the others are constant, right? All the others are constant. So we can eliminate the others. We can say the voltage is proportional to V square. This method I already teach you last time in first semester. I hope you still remember. Okay. So the constant, these E and M, they are both constant. So that means if I divide both conditions, actually I will have two equations. You understand? If I have two situations, means I have two equation. I will have two equation, equation 1 and equation 2. I just substitute. Let's say the equation 1 is using V1 and voltage 1 and velocity 1. I also the second equation I use V2 and velocity 2. And then I have two equation. I have two equation, equation 1 and equation 2. So I divide the two equation. The constant value, E and mass, the electron charge and the mass, which they are constant, they will be cancelled out. They will be cancelled out, and they will left with only this one. Only left with this one. Because why the E and the mass gone already? Because they are being cancel out. We can just write here the E and M. I just write at the top here. They are being cancelled. They are being cancelled away. Yeah, cancel out. The E and M. So and the half also. And the half also is a constant value, also being cancelled out. So the two equations I divide. I got this formula. Yeah. This equation 1, I use equation 1 divided by equation 2. I got this formula. Or the simplest way to know, you don't need to think about the divide. Yeah, is you just say since there are only two constant, the voltage and the speed, they are only the voltage and the speed changing. So the constant, or you can just omit. You can just say the voltage proportional to the velocity. Voltage proportional to the velocity square. So if proportional, you can write like this. V1 and the voltage 1 and the velocity 1, they are same level. They are at the same level. Understand? They are the same level. Because this one is the voltage and the V square on the same level. So V1 and the V1 and the same level. V2 and the voltage 2 and the velocity 2 also same level. Also same level. That's it. If they are at different level, which means like this. This one at different level. You see that? Different level, then will be something like this. If at different level, if lambda at the top, velocity at the bottom. So what happened is the lambda 1 and the velocity 1 will be crossing. One at the top, one at the bottom. If lambda 2 at the bottom, velocity 2 at the top. That what I means at different level. Yes, you see that? I like this. I like this. Okay. If voltage and velocity at the same level, then you write V1 and V1 same level. V2 and V2 also same level. Okay. So now, what's the question need? He want us to find the ratio of velocity 2 over velocity 1. He want us to find this. Velocity 2 over velocity 1. So, this one is velocity 1 square over velocity 2 square. So, I need to change it. I need to invert it. Invert it becomes what? It becomes V2 at the top and V1 at the bottom. So this velocity 2 also at the top, velocity 1 at the bottom. So this one, V2 become V2 over V1 square, like that. Okay. So now I want to find the V2 over V1 here, isn't it? So what I do is I square both sides. I want to remove the square. This is all mathematics. This is all mathematics. I square both sides, square root both sides, square root both sides to remove the square. Yeah. This one, this square I combine, become here, and then I want to remove this square because I just want the V2 or V1 inside. Okay. Square root both sides. So finally, I will get V2 over V1. This is velocity, which is equal to square root voltage 2 over voltage 1. So what is voltage 2 again? Voltage 2 is we no need to use the value because we know V2 is half of V1, so we can maintain the variables. V2 is half of V1. What I know is V2 is half of V1. So V1 and V1 can be cancelled out. V1 and V1 can be cancelled out. So in the end, what do I get? What do I get for square root 0.5? Okay, this is actually velocity 2 over velocity 1. Okay, I get half is 0.5. So square root 0.5 is 0.7071. That's the answer for the part A. Okay, 7071. That's a ratio for this speed. Now, what about B? Ratio of electron new wavelength to original wavelength. So I want lambda 2 over lambda 1. So wavelength, electron wavelength. How to relate the wavelength of electron to voltage? How to relate? So first of all, we have the we already got the ratio of speed. We can make use of this speed. Yeah, we can make use of this speed. Now, ratio of new wavelength to original wavelength. So what's the formula for wavelength of electron? The de Broglie formula. This is the de Broglie formula. Lambda equal to h over mv, isn't it? Lambda equal to h over mv. So what I can say is, which one is constant? The constant is the mass is constant. The mass here is constant. See, the mass here is constant. The h also constant. So what changing is only what? What changing is only the lambda and velocity. You understand or not? It's only the lambda and velocity. So the mass is constant. So I can say lambda is inversely proportional to velocity. Inversely proportional to velocity. You see here? Lambda at the top. Lambda at the top, velocity at the bottom. So this means that if I form equation for two conditions, lambda 1, if lambda 1 at the top, velocity 1 at the bottom. If lambda 2 at the bottom, velocity 2 at the top. Yeah, this one also I form equation for two equation. I form one equation and two equation. For equation 1, I put this as lambda 1, this as v1. And then for equation 2, I put this as lambda 2, this as velocity 2. And then I take the two equation, equation 1 divide by equation 2. and this is what I get. This is the what I get. Understand? I just use a simpler way to get it. Yeah, I no need to divide and cancel so many things. Yeah, so I got this formula. Now to get I need the ratio of lambda 2 over lambda 1. This one is lambda 1 over lambda 2. I need to rearrange. I want lambda 2 over lambda 1. So this one also invert, become V1 over V2. Remember, this is velocity, not the voltage. This is velocity. So the question gives us the voltage. It don't give us the velocity, but the ratio of velocity you already get from A. You see, the part A already have V2 over V1. Part A we already have V2 over V1. So why don't we make use of this? We make use of here V2 over V1. We can put into here. But this one is V1 over V2. This one is V2 over V1. That means what? That means this is equal to 1 over this one V2 over V1 is square root. Don't use this decimal place. Not so accurate. Use the one still in the third form. Yeah, use the one still in the third form. So this is V2 square root 0.5. So invert V1 over V2, it become 1 over third 0.5, isn't it? Then only you calculate the question, calculate for the answer, and then I get 1 over this one. I get the answer 1.414. That's the lambda 2 over lambda 1. Is that correct? Is the answer correct? Let's check the answer. For question A is 0.71. That's correct, 0.71. And then for question 2 is 1.41. 1.41. Yes, that's correct. Okay. Or for question B, if you don't want to use the velocity, we want to use back the voltage, also can use the other formula. Use the other formula, which is lambda equal to h over, this is a bit long, which is 2 ME voltage. This formula also can. So if you want, all the others, they are constant. So we only have all the others are constant. H is constant, mass is constant, electron charge also constant, because all we use the electron only. So the mass and the charge is the same. So the only thing changes is the lambda and the voltage here. So all the others, they are constant. H2 ME, they are constant. So I can make an equation like that. I can make equation, okay, lambda is inversely proportional to 1 over third voltage. 1 over third voltage. You see that? 1 over third voltage. So what I can make equation is, I can make lambda 1 over lambda 2 equal to, remember, this one is inversely proportional. So if lambda 1 on top, the V2 need to be, the V1 need to be below. Okay, if lambda 1 at the top, V1 at below. If lambda 2 below, the V2 at the top. The V2 at the top. That's it. Yeah. Because they are at the different level. If different level, then make it different level. Yeah. One top, one at the bottom, another one at the bottom, another one must be at the top, like that. Okay. So we want lambda 2 over lambda 1. We want lambda 2 over lambda 1. So this one need to make invert also. Remember, this one can simplify to V2 over V1. And the third is combined. So we want lambda 2 over lambda 1. So I also invert this one, lambda 2 over lambda 1. So become, this one also invert, become V1. This is voltage, not velocity. Okay. So remember, this one 2 and this one is like that. Yeah. Inversely proportional. So 2 at the top, lambda 2 at the top, V2 must be at the bottom. Okay, so what's the voltage again? So just now he say the V2 is half of V1. V2 is half of V1. So let's calculate. Yeah, let's calculate. V2 is half of V1. V2 is half of V1. So I can cancel the V1. I actually no need the value of V1 also. The value here 1250 is useless. No need. I got cancelled off. And so finally, what's the answer? I get the lambda 2 over lambda 1 is third 1 over 0.5. You see that? This half is 0.5. So it's exactly the same. Exactly the same answer. You see that? Back to the same answer like this one, isn't it? So this is the so the lambda 2 over lambda 1 here still 1.414. You get back the same answer. Okay, so there are many approaches to do these questions. You want to use the de Broglie formula or you want to use this formula also can. This formula actually is combined already between the formula at part B and also formula at part A. They combine together. They combine this formula and this formula together, and we get this formula. This formula we can get from the list of formula. It will be provided in the exam. Okay, it will be provided in the exam. So I bet, but for me, I like to memorize lah. I like to memorize the formula. Okay, so just use whatever formula is easy to you. Just use whatever formula is easy to you. Okay, so there are many ways to do these questions, and let's move on to the next one.